Hi everybody, today for once I'm not going to demonstrate a math question, I'm going to demonstrate a principle. So let's say somebody gives me 100 feet of fence. So 100 feet of fence. And they say to me that I can make an enclosure of any shape I want, but the goal is to enclose the biggest amount of area with that enclosure. Makes sense? So for instance, if I had a square, then all the sides would add up to 100 feet. If I had a circle, same thing. Or if I had a rectangle, same thing. Triangle maybe. So my question to you is, what do you think the shape is that I could enclose the most area with if the outside has to measure 100 feet? Well, let's find out. Let me start with a square. So kind of easy to picture. If I have 100 feet, each side would be 25. The perimeter would be 100. And how much area is that? Well, area of a square is base times height, length times width. So 25 times 25 is 625. So let's see what happens if I make a rectangle instead that's a little bit of a different shape. So let's say these two long sides are 20 and then these two sides are 10. So that still adds up to, oh, no, that doesn't add up to 100. Hold on. What I meant to say is 40, 40, 10, and 10. That adds up to 100. Okay, back on track. So I still am using 100 feet of fence, but now look what happened to my area. It's only 400. So kind of weird, right? Even though I use the same perimeter, 100, since I stretched it, it's getting smaller. And look what happens if I stretch it even more. Like, let's say that this is 45, 45, and then this is 5 and 5. That still adds up to 100, but now that's 225. So kind of funny, but the more I stretch my square, the smaller the area gets. So with that principle, you might be able to tell that a circle actually holds even more area, and in fact, that's the shape with the biggest area. So let's say that the circle's circumference is 100 feet. So remember, the circumference of a circle is 2 pi r. Let's say that that's equal to 100. Well, let's try to figure out what the area is based on that. And to solve for the area, we would need the radius, right? Because the area of a circle is pi r squared is the area. So let's see what happens if we do this. Let's divide both sides by 2 pi. So let me see if my calculator has a pi on it. It does. Pi is about 3.14, and I'm going to multiply it by 2. So I'm going to get about 6.23. So I'm going to do 6.283 rather. So I'm going to do 100, what I'm kind of doing here while I'm talking out loud, is I'm dividing both sides by 2 pi. And I'm approximating 2 pi is 6.28. So I'm going to do that. 100 divided by 6.28, and I'm going to get that the radius is 15.9. And these are approximations. I'm not going too crazy with decimal places. So if the radius is 15.29, let's square that. 15.9 times 15.9. Did I say 15.29? Let me just redo that really fast. Pi times 2, 100 divided by 6.28. Sorry, guys. Just making sure so you don't yell at me later. Yeah, 15.9. So 15.9 squared is approximately 252.8. So that's the r squared. And if we multiply that by pi, we get 700, about 794. 794. So as you can see, that's way bigger than the square if we use the same 100 feet of fence. So the takeaway is that sort of the more circle-like a shape, the bigger the area we can enclose with the same perimeter. The more we stretch the shape, as we can see by our rectangle examples over here, the smaller the area is getting. So you can kind of use that principle maybe to guide you in a math problem someday. Don't know when it's going to happen, but I've seen it happen once or twice over the years in GRE or SAT or ACT style problems. So, might come in handy. Hope you enjoyed it.